So 6.3, we're going to be graphing radical functions. So we're going to look at square root functions and cube root functions. And the transformations that we're going to do with that are the same transformations we've done with quadratic functions and cubic functions. Okay, so you should hopefully be able to recognize what's going on. We're still going to do two tables, one for the parent function, one for the transformation function. So two graphs, state the transformations. For square roots, we're going to look at, we have an endpoint. With cube roots, we have an inflection point. Okay, so we're going to talk about the difference between that. We're going to do domain and range for each problem. Okay, so before we start, we're going to look at the parent function. F of x is equal to the square root of x. So this is the inverse of f of x equals x squared. Okay, so if you think about when we did quadratics, okay, so a little background, f of x is equal to x squared. Every time we did that table, our values for the x's were -2, -1, 0, 1, 2. Y'all remember that? Okay, and then -2 squared would be 4, -1 squared would be 1, 0, 1, 4, and it would give me a parabola like that. Okay, well, here you're taking the square root of x. Okay, so think about our rules for square roots. Okay, if I were to take...
Teachers and students, please pardon this announcement. Due to traffic issues.
Since we are taking the square root, if you take the square root of a negative number, what does that give you? I. It gives you imaginary. So when we're doing our graph is an XY grid, we don't have imaginary parts for what we do. Okay? So if we're not going to have imaginary parts, we can't have negative numbers in our table. Okay? So, if you can't have a negative, we're going to have to start at 0, 0. Okay? That 0, 0 is why you have an endpoint for the square root functions, because I cannot go negative. Okay? Now, you have to think about, we're plugging in something under this square root. So think about that when you're doing your x values. Okay? Can I plug in a 1 and take the square root of 1? Yes, that's a 1. But can I take the square root of 2? It's not going to be a whole number to go on your graph, so we're not going to do that. Square root of 3 isn't going to give me a whole number. So my next x value would be the square root of 4. So if I plug in 4 for x, what's my y? 2. So then what would be my next value in my table? 9. The square root of 9 would give me 3. Okay, my next one would be 16, which isn't going to fit on my graph, so I'm not going to do that. So this will be the parent function table that you need to memorize. Okay, which by the end of this lesson, you're going to have it memorized because we're going to do it every single example. Okay, so what does that graph look like? We'll plot those points. Okay, now I said I had an endpoint at 0, 0, but it goes on to infinity as I go to the right. Okay, so I'm going to have my endpoint, go to the right, and put my arrow. Okay, so if you compare this to what a quadratic is, you're just basically turning it sideways. We're going to talk about inverse functions. It's the last lesson of the next chapter, next unit. But this is basically just half of this. You're not considering the negatives. Okay? So if I am looking here, I need to label and state my domain and range. Okay? Your domain is a set of all possible x values. Okay? Remember, we have discussed interval notation and set builder notation. Okay? If you do set builder, then remember you've got the x such that x if I'm looking at my x values, I'm starting at my endpoint, which is 0, and I'm going forever to the right. So that would be x is greater than or equal to 0 if I did set builder. Now, if I did interval notation, it would be a bracket at 0, because that's my starting point, going to positive infinity. Whichever one you want to do, I'm good with, as long as you have it there, okay? Now for your range is your set of all possible y values. So your range, you're going from the bottom of your graph all the way to the top, okay? So I know that range is my y, okay? I have an endpoint at 0, and then even though it looks like it's only going to the right, it's forever going up as well, okay? So that means y is greater than or equal to that 0, the y value of the endpoint. Okay, now again, if I did interval notation, it would be 0 to positive infinity also. So that's for my parent function. Okay, so now we're going to look at transformations. Do we have questions about our parent function and why this is the way it is? Okay, so now I have the square root of x plus 3. Okay, it's a square root, so I know my parent function is f of x equals square root of x. So my parent function table, 0, 0, 1, 1, 4, 2, 9, 3. Question. If you wanted a second color, you can do a second color. I haven't been doing it, but if you want to get that out, you can. When we build our transformation table, remember that it's all the same transformations as if it were a quadratic or cubic function, okay? If it is underneath the radical, then it's happening to your x. Anything else is happening to your y, okay? You should be able to recognize that. So if I have x plus 3 in my function, what am I putting in my table? X minus 3. Remember that x is the opposite of x minus 3. X is a liar. You do the opposite of. Okay, is anything happening outside of the radical and affecting your y? No. So my y stays the same. Okay, y'all remember building your tables for transformations? Okay. So I'm going to take my 0 minus 3, that gives me negative 3. 1 minus 3 gives me negative 2. 4 minus 3 is 1. 9 minus 3 is 6. And then I copy down my y's, 0, 1, 2, 3. And I'm going to plot those points. So now where's my new endpoint? Negative 3, 0. We're going to start abbreviating that to EP, but for now I wanted you knowing what that was. Okay, so our endpoint is at negative 3, 0. Okay, what transformation did we have? It went to the left 3 units, so shifts or translates left 3 units. Okay, so for my domain, you want to do set builder or interval notation? Okay, interval is shorter. So your interval notation for your domain, where am I starting for my x? Negative 3. It should be the x value of that endpoint, and it's going to positive infinity. For my range, where is it going? From where? Okay, so remember your range is your y. So you're going to use your y value, 0 to positive infinity, because it's going to go forever upwards. Okay, are y'all good with that? I'll give you a copy. Just make sure you're paying attention and getting what you can. Okay, so my next example is negative square root of x minus 1 plus 4. So my parent function again, f of x is equal to square root of x. Okay, and my table is 0, 0, 1, 1, 4, 2, 9, 3. Okay, now if you look at your function, for my x, what is happening to my x? What should I put in my table? X plus 1. It says x minus 1 in my function, but it's the opposite, so x plus 1. And then for my y, what am I going to have? So you have the negative out front, so negative y plus 4. So anything that is outside of your radical, you put for your y. Okay, so I have 0 plus 1, which is 1, 1 plus 1, which is 2, 4 plus 1, which is 5, and 9 plus 1, which is 10. Okay, now negative y plus 4. You're going to multiply your y by negative 1 and then add 4. So 0 times negative 1 is 0, plus 4 is 4. 1 times negative 1 is negative 1, plus 4 is 3. 2 times negative 1 is a negative 2, plus 4, which is 2. And then the last one becomes negative 3 plus 4, which is 1. So what is my endpoint now? 1, 4. Okay, I had 3 transformations. That negative tells me it reflects over which axis? Okay, remember your reflections are the opposite of. So if it happens to your y, then I'm reflecting over the x-axis. Okay, this x plus 1 shifts it where? Shifts it to the right 1 unit. And where else did it shift? Up 4 units. Okay, my domain, I'm still going to the right. Okay, so my domain, I still look at my endpoint. The x value of my endpoint is 1, and I'm going to positive infinity. But what do you recognize about this graph when you look at your y's? It's going down now, right? I'm starting here, and now my graph is going in the downward direction. Okay, so if my range is bottom to top, then technically I'm going from negative infinity, and I don't go any higher than that y value of my endpoint. Okay? So if you have a reflection over the x-axis, your range is going to go from negative infinity to the y value of your endpoint, because it doesn't go any higher than that. That's your max. Okay? Alright, f of x is equal to 2 times the square root of x plus 2 minus 1. So my parent function, f of x, is equal to square root of x. 0, 0, 1, 1, 4, 2, 9, 3. Okay, what do I do for my x column for my new table? X minus 2. My function says x plus 2, but it's the opposite of, so I do x minus 2. And then for my y column, what am I going to have? 2y minus 1. So you take your y's, multiply it by 2, and then subtract 1. Alright, so for my x's, 0 minus 2 is negative 2. 1 minus 2 is negative 1. 4 minus 2 is 2. And 9 minus 2 is 7. And then for my y's, 0 times 2 is 0 minus 1 gives me negative 1. 1 times 2 is 2 minus 1 is 1. 2 times 2 is 4 minus 1 is 3. And 3 times 2 is 6 minus 1, which is 5. Okay, so what's my new endpoint? Negative 2, negative 1. What are my transformations? It's a vertical stretch by a factor of 2. Shifts left 2 units and down 1 unit. What's my domain going to be? Very good. And my range? Very good. Y'all good with that? Do we have questions over square root functions? Okay. Y'all feel pretty confident about your transformations? Okay, now we're going to talk about cube root functions. Okay, so the square root of x was the inverse of f of x equals x squared. So the cube root of x is going to be the inverse of f of x equals x cubed. Okay? In the same context, we had, for that parent function, negative 2, negative 1, 0, 1, 2. So negative 2 cubed would be negative 8. Negative 1 cubed was negative 1. 0 cubed was 0. 1 cubed was 1. 2 cubed was 8. Okay? And remember, our graph looked something like this. Okay? We didn't have an endpoint with cube root functions like we do with square root functions, because square roots, the whole reason you have an endpoint is because you can't take the square root of a negative. But remember, you can take an odd root of a negative. You can take the cube root of a negative number. So we have in the center of our graph, remember inflection points? The inflection point is where it starts to flatten out, which is going to be the center. So for the parent function of a cubic function, it was 0, 0. Okay? So if we're doing the inverse, when I do my parent function table, I don't want to plug in a negative 2, negative 1, 0, 1, 2, right? Because I'm not going to take the cube root of a negative 2. What can I take the cube root of, though? Negative 8. I'm going to be taking this and essentially flipping it. I can take the cube root of negative 8, and that would give me negative 2. Then I can take the cube root of negative 1, and that would give me negative 1. I could take the cube root of 0, that gives me 0. The cube root of positive 1 is a positive 1. And the cube root of 8 is a positive 2. Okay? So you're going to have to memorize that table. You're going to have to know when is it a square root and when is it a cube root. Well, the only difference is this index right here. So if you can recognize, there's my cube root, I do this table. If it doesn't have the 3, then it's a square root. And you do the other function. Okay? On your worksheet, they're going to be separated. But on your test or your review, they're going to be mixed together. So you're going to have to know which table goes with which. Okay? So if I graph this, negative 8, negative 2, negative 1, 0, 0, 1, 1, and 8, 2. When you graph that, what do you notice about the cube root of x versus x cubed? It's just on its side. Okay? So, the reason you have the full graph here is because of the fact that you can take the odd root of a negative, unlike the square root. Okay? So, our inflection point, where it flattens out, is in the middle, which is at 0, 0. Okay? Now, my domain, I don't have an end point. I have arrows on both ends. So what would my domain be? Negative infinity to positive infinity. Or if you wanted to do set builder, that's your XER, your all real numbers. Okay? For my range, same thing. I have an arrow on both ends. It's going to be negative infinity to positive infinity for every single cubic function. So set builder would be YER, which is your Y is a member of all real numbers. Okay? So, if I'm looking, the cube root of x minus 2, I'm going to do my parent function, f of x equals the cube root of x first. So negative 8, negative 2, negative 1, 0, 0, 1, 1, 8, 2. Okay, if I'm looking at my transformation function, cube root of x minus 2, that's happening to my x. What do I put in my table? X plus 2. It's the opposite of. Is anything changing my y? Is anything happening outside the radical? No, it's just y. So I'm going to take my x's. Negative 8 plus 2 is negative 6. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 8 plus 2 is 10. And then my y stay the same. Negative 2, negative 1, 0, 1, 2. So once you graph that, we now have to state our new inflection point. Okay, so if our parent function inflection point was 0, 0, that became 2, 0. The middle of your table, which is the middle of your graph. Okay, what was my transformation? It shifts right 2 units. domain would be negative infinity to positive infinity, in my range, negative infinity to positive infinity. That domain and range will be the same every single cubic function, no matter what. Okay? Do y'all get what we're doing? Okay. Can y'all just verbally tell me what would happen here? Okay, x minus 2, y minus 1, it would shift left 2 and down 1. Okay, let's do this one. And we're going to throw a 2 in front. If we can do this example, then I'm going to let you do your worksheet. Okay? Alright, so my parent function is f of x equals cube root of x. Okay, for my table, I have a negative x minus 1 underneath the radical. So I'm going to have negative x plus 1 for my table. Because you still have to keep that reflection for your x. But that negative 1 for the translation, that's going to change to a positive 1. And then what is happening to my y? 2y plus 5. Very good. Okay? Negative x plus 1. We are taking our x value, multiplying it by a negative 1. All you're doing is changing the sign. And then adding 1. Okay? So this negative 8 becomes positive 8. 8 plus 1 is 9. The negative 1 becomes positive 1. Plus 1 is 2. 0 plus 1 is 1. Alright, the positive 1 becomes negative 1. Negative 1 plus 1, 0. 8 becomes negative 8. Negative 8 plus 2, negative 6. Oh, my bad. I don't know where I got that plus 2. That should be a 7. Negative 8 plus 1 is negative 7. Then 2y plus 5. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. Negative 1 times 2 is negative 2. Negative 2 plus 5 is 3. 2 times 0 is 0 plus 5 is 5. 1 times 2 is 2 plus 5 is 7. 2 times 2 is 4 plus 5 is 9. So what's my new inflection point? 1, 5. Okay. What was the 2 representing for my transformations? Vertical stretch by a factor of 2. Okay, what was the negative on my X telling me? Reflection over the y-axis. And then the shifts right 1 unit and up 5 units. And my domain would be negative infinity to positive infinity. My range would be the same. Okay? Do we have questions on that? Do we feel okay with the rest of the transformations? Okay, so you will have a quiz over 6.2 and 6.3 combined next class. Okay? Come see me if you have questions.